So thank you so much for having me. This is the list of presenters that will be coming after me. My name is Rachel Hurtis, and I am one of the physicians at Lucille Packard. I'm a pediatric gastroenterologist, and it's a real pleasure to be here and just be a small part of the Food Summit. So my research focuses on the metabolic dysfunction-associated steatotic liver disease, and that's a really long way, but I'll be calling it MASLD. Some people call it MASLD, some people call it MASLD, MASLD, whatever you choose to call it. It is formerly known as non-alcoholic fatty liver disease, so that might sound more familiar to you. And my focus really is to have equitable, feasible, and culturally tailored dietary modifications for pediatric patients and their families. And so the definition of MASLD is hepatic steatosis, which is fat infiltration into the liver of greater than 5%, and a cardiometabolic risk factor. And those cardiometabolic risk factors include things like overweight or obesity, impaired glucose metabolism like diabetes or insulin resistance, hypertension, and dyslipidemia. And why we care about this disease is because we know that 20% of kids in the United States are overweight or obese. And of those 20%, about a third of them will have hepatic steatosis, and that is more common in those of Hispanic and non-white ethnic backgrounds. And what you can see from this little pictogram at the top is that the reason this is important is that when you have chronic fat infiltration into the liver, you can, this will eventually lead to fibrosis, which is reversible scarring, and then can lead to cirrhosis or irreversible scarring, and finally put people at risk for developing hepatocellular carcinoma. And while it's not exactly known how many kids will progress to fibrosis from fatty liver infiltration, it's estimated to be between 10 and 30%. And so there's several options for the treatment of MASLD that have presented themselves in the scientific literature and in clinical practice. The American Association for the Study of Liver Disease and most clinicians will recommend that lifestyle modification should be the foundation of treatment for MASLD. And what's interesting is that most treatment options relate to weight loss strategies, because we know that a 5 to 7% loss of excess body weight can help reduce fat infiltration into the liver. But what's interesting, and what Dr. Gardner sort of alluded to, is that the Mediterranean diet, or diets that are plant-forward, are also known to be effective at reducing hepatic steatosis and without actually augmenting weight. So the ideal diet and the ideal treatment for MASLD is not yet known, especially with regard to children. So in pediatrics, we are trained to treat overweight and obesity with the 5-2-1-0 rule, which emphasizes a restricted intake of food products such as sugar-sweetened beverages, added sugars, trans fats, and processed foods. And this, of course, makes sense, as we know that from studies that saturated fats and simple sugars such as sucrose and fructose, trans fats, and some animal fats can lead to the aforementioned cardiometabolic risk factors. And they can also cause injury to the liver by modulating the accumulation of triglycerides, reducing antioxidant activity in the liver, and changing glucose metabolism. However, there's evidence that restrictive recommendations in the pediatric population can often backfire, leading to a temporary reduction in whatever you've restricted, followed by an overall increase in those restrictive foods or beverages. So in other words, are we making the situation worse with our current restrictive recommendations for kids? Alternatively, we know that diets that encourage more plant-based proteins, fiber, and omega-3 fats have been shown to prevent and treat hepatic steatosis. So with this in mind, we developed a project whose aim was to evaluate the use of a non-restrictive diet with emphasis on a plant-forward products and high dietary fiber to treat pediatric MASLD. Our project hypothesis is that pediatric patients with these dietary modifications will have improved dietary change longevity and clinically significant reduction in ALT levels over time. And our team has defined a high-fiber diet as one that reaches the recommended daily intake for fiber for age. And this might seem like an easy target, but what we know from the current literature is that kids and adolescents only take in about a third to a half of the recommended daily intake for fiber. And in one study of the U.S. National School Lunch Program found that elementary students only consume about 7% of recommended fiber intake, while they consume about 89% of calories from fat and 98% of recommended sodium intake. So the current status of this project is a work in progress. I believe that clinical research should be reflective of the actual needs and wants of the patient population rather than the perceived needs. We're starting our study with a patient and family-centered semi-structured interviews, and then we'll develop focus groups so that our pilot study will be medically and culturally tailored to the needs of our patients and the lived experience of those patients. The interviews and focus groups will help us to define feasible strategies to increase fiber intake in children's diets. And we hope to complete the qualitative research by mid-2025 and start the pilot study by the end of 2025. Thank you for your time.
Good morning, everybody. Thank you for this opportunity. And my involvement in this project started almost 4 years ago. And then I started collaborating with this amazing team about 2 years ago. We continued the collaboration, and we will be continuing. So my call in this particular area is mainly because of the family needs. Because, about 5 years ago, my wife was diagnosed with cancer. At that time, about chemotherapy, she was in remission for about, 4 years. And then 2 years ago, I was diagnosed, and my wife cancer relapsed at the same time. So unfortunately, but then I was working on this, therapeutic diets. So I used to add Alzheimer's disease preventive and also cardiovascular preventive. Then when after both of our diagnosis, I added cancer preventive as well. So most of the ideas we developed and the material and also the food material we developed, focus is developing therapeutic molecules, therapeutic food products, vegan-based, and we use it actually myself. Every day morning, I take a breakfast of the material I made by this project, thanks to Chris and team and Jennifer and other people for their sustained support and also encouragement. Yeah, so let me go to the slides. Yeah, so incorporating plant-based material to enhance the sensory profile and plant-based thing. Basically, we just use the insoluble fiber as a base. Initially when we started 2 years ago, we thought we can replace it with methyl cellulose. But right now, we are not focusing on that. We are still using the methyl cellulose based. And then, of course, any alternatives, we looked at the tapioca, other kind of pectins. But right now, whatever, we are using it, for our purpose, we use only the cellulose-based one. So what is basically, it's a part of the Bhavika's, one of the postdoc involved in this project, her work. So maybe all of you know that we have about 5 tastes, right? Salt, sour, and all. Perhaps I don't know how many of you are aware, they also found out the 6th taste, that's a fatty taste. The taste, the texture, and the taste you have because of the animal meat, they think it is because of the 6th taste bud. It is this one, the CD36. This is a receptor. It's almost like a spoon, interestingly. And then we wanted to find out why, when of course, I never eat beef. And people told me, when we eat the vegan substitute and the beef side by side, you can definitely find the difference. What is the reason for the difference? We think by our research, it is this receptor. This receptor got the sensitivity to specifically have the taste sensation for that fatty material. So that how the fatty material is ingressing into the protein fibers in the animal fat. So we wanted to replicate in the vegan. Not that, to say that the animal fat is the best and vegan fat is an imitation. I'm not talking about that. I'm trying to find out the way that our system, which evolved, for several years, so I'm trying to do that. So we did thanks to the latest computational technology, we developed a lot of the mutational, structures, and then we tried to dock it. And then we found out, like both oleic acid and stearic acid, they bind extremely well with that. And other molecules are not binding. So we checked all the vegan meat substitutes, whether they use these molecules. Whenever they use the molecule and properly in a deliverable form, we found out that they have a very good correlation. I'll just quickly go through that. So this is Bhavika's work. And then we use the curcumin and also how we formulate it. And this curcumin, we use curcumin for making fruity jelly, and jelly in G, because we use the technology how deliver into the intestine very, very, very effectively this therapeutic molecule. Yes, so this is, and of course, during the pandemic, I took both curcumin and moringa isothiocyanates in our therapeutic formulation. We sent it to my collaborator in UK, and then he screened it. And surprisingly, we found out the curcumin got an amazing, anti-cancer activity as well as, we did the studies thanks to thing, and we also developed a good science to find out how exactly in this case, the saturated fat is also, especially stearic acid, is promoting regeneration in the mitochondria as well. So that means by properly delivering even the saturated fat, the vegan-based saturated fat, we can have a very good therapeutic outcome. So for the details, you can approach me by email. And these are all the people, of course, Chris, I have to thank him. And also my mentor, Edgar Engelman, and Jennifer Robinson, I wanted to thank her. And Bhavika ma'am, the postdoc, and Venugopal, another scientist, and Mohammed is another scientist, and all these people helped me, and my collaborator in UK who did all the antiviral work for all the therapeutic molecule. Thank you very much.
Good morning. So I work with Dr. Becker. I'm a postdoc in his lab. And the focus of my research is on how fermented food affects gut motility and the gut immune system. Okay. So we know that DGBIs, which are diseases of gut-brain interaction, they are basically a heterogeneous group of disorders which are characterized by gastrointestinal symptoms. And overall in the world, there's like 40% incidence, and as you see, the Western world has more significant incidence of DGBIs. And it's a significant healthcare burden on both patients and the healthcare system, and women are preferentially affected more in DGBIs. And we see that in the US, it's like 69% of all the US population has some sort of a GI symptom. And there's been a lot of treatments that are proposed for DGBIs, and it's a mix of diet-based treatments, microbiota-based treatments, and of course, drugs. So we have anti-inflammatory drugs, and we also have like neuromodulatory drugs because they also provide symptomatic relief. And then you have the microbiota modulation, which is basically probiotics and antibiotics and FMT. And lastly, we have diet-based or lifestyle-based modulation. And a lot of these treatments, while they address the symptoms, they don't address like the root cause or the triggers, and they also are seen to gradually lose efficacy. And long-term feasibility of treatments, even the antibiotics, is in question. And while the diet treatments like the low FODMAP diets, they have been shown to be effective, but they are still very restrictive diets, and people find it difficult to sustain those treatments long-term. And we have the recently published paper by the Sonnenberg lab where they showed that a high fiber diet and a high fermented food altered the immune response in the gut, and they also increased like the microbiota diversity. And they used a lot of different fermented foods, but of particular interest to us was the vegetable brine drink that they use. It's called Gut Shot. And we collaborated with them, and we wanted to use the same fermented drink to see the effects on gut motility. And so our first focus was gut motility, and we did a lot of tests for gut motility. So we measured colonic motility through the bead expulsion experiment, and the whole gut motility through this by gavaging a dye, which we then measure in the stool, and then fecal water content, which is also an important function of the gut. And we found all three, like the colonic motility and the whole gut motility, statistically significantly decreased, which we see as an improvement in case of motility disorders like constipation. And fecal water content, though not significant, you still see a decrease. And the focus of our research is on the gut muscularis, because this region is important in motility disorders. This is the region that influences gut motility, and we focus on the gut macrophage cells because these cells have been shown to be important in motility disorders. And so to this end, we looked at the immune system, and as you see, macrophages are dominant cell types in the muscularis, but overall there doesn't seem to be any difference in the immune cell population as a whole. So we then focused on just sorting the muscularis macrophages, and we found that TNF-alpha, which is an inflammatory cytokine, is significantly decreased in the muscularis in fermented food-treated animals, and IL-1 beta, which is also another inflammatory cytokine, is also seeing a trend of decreasing. And we found this only in the small intestine, interestingly, not in the colon. And we looked at some of the other phenotypic markers of these muscularis macrophages. None of it seems to be altered. The homeostatic and the signaling genes remain the same. So the only significant difference is that inflammatory cytokines go down with fermented food. And then we looked at it through ELISA, which is just another way to verify the same result, and we got a significant decrease in the TNF-alpha in the muscularis tissue as well. And we then looked at the microbiota, because diet has been shown to alter microbiota. While we did not find a significant overall decrease, we did find a decrease in a lot of genera. We interestingly found that many of them converted lactate to butyrate. Many of the significantly altered genera converted lactate to butyrate. And then we then looked at the metabolomics, and then we interestingly found that these fermented food-treated animals have significantly increased levels of acetate and marginally increased levels of butyrate. And we are doing further studies on old mice to see if, because motility disorders are commonly seen in old people, so we want to see if there's any effect on older subjects as well. And so in summary, we find there's a decrease in the transit times, and then TNF-alpha, a key inflammatory cytokine, is decreased, and while some genera level changes are there, and we do find some short-chain fatty acids that are altered. And we are delighted to say that we have observed a similar decrease in the motility in older subjects as well, so it might definitely prove to be a potential therapeutic option for DGBIs. Thank you.
Well, I want to thank Christopher Gardner, his lab, Jennifer Robinson, Meg Orchiari for just this incredible summit. I'm delighted to be here today presenting on behalf of my amazing colleagues, Dr. Neha Shah, who's an integrative rheumatologist here, and Dr. Marian Mikowski, who's a nutrition scientist with the WellMD program. My name is Tamiko Katsumoto. I'm an adult rheumatologist, and I am very much interested in food as medicine, and we're talking about the PLANT study, which is providers learning about nutrition together. So by way of background, I want to set the stage. The rationale for this study was really leveraging healthcare providers to be agents of change, really to promote sustainable plant-centered diets. I think we can all appreciate there's a huge amount of data supporting the fact that there are tons of benefits of plant-based diets, good for human health, good for planetary health. The problem with medicine these days, we have been very much focused on treatment, medications, procedures, interventions. We have not been focused on prevention. And we know that nutrition and lifestyle are unfortunately not emphasized in our current medical curriculum. In fact, only about a quarter of medical schools provide the minimum 25 hours of nutrition education. The good news is that most patients are very eager to eat sustainably. In fact, 59% say that sustainability is an important aspect of their food choices. And the better news is that 78% of patients say that they've changed their own eating habits directly as a result of conversations with their physicians. And I can actually personally attest to this. Healthcare providers are considered highly trustworthy and reliable. And just imagine this as a thought experiment. If you had a patient panel of 1,000 patients a year, which is on average, you could influence 3 meals a day. That's over 1 million meals a year. I'm going to show you this exciting survey that came out from the International Food Information Council just this year, showing that among potential sources of food information, the most trusted people are people like Christopher, food scientist, but the second most trusted are medical doctors and nurses, even though we don't get good education. So we decided to leverage this fact and turn it into something real. So our hypothesis for this study is that healthcare professionals exposed to a 6-week multimodal nutrition educational intervention on whole food, plant-based diets, targeting the 3 primary learning styles, visual, auditory, kinesthetic, would be more likely to adopt a whole food plant-based diet and, importantly, feel more confident in recommending this to their patients. So here's our study design, RCT. This is a randomized delayed intervention study. We randomized about 100 healthcare providers, 1-to-1 to the early intervention group A versus a delayed intervention group B. We took surveys every 3 weeks, and we took our primary endpoint at week 6. And here was a 6-week intervention, very exciting. We started off with a bang with Dr. Christopher Gardner talking about protein myth-busting on unapologetic deliciousness. Dr. Neha Shah and Marian Mikowski talked about the plant prescription, inspiring patients through whole food plant-based nutrition. We had a cooking class. I gave a talk about sustaining the planet 1 meal at a time. And then Neha gave a tour through her pantry, how to stock your whole food plant-based pantry. And finally, we ended with a really nice cooking class taught by Carly Arbo, who's a chief resident in surgery here and a chef, as well as Marian Mikowski. So here's our consort diagram. We screened 159 people. I want to say participants, not patients, participants. And we randomized 102. These are healthcare providers, 1-to-1. Very little dropout, really good retention. And I want to show you our table 1 of baseline characteristics. What is eminently obvious is that these were female, 95% female. This is an issue, but we'll talk about that. And the majority of the people that were involved were either attending physicians or advanced practice providers. We did have a handful of dietitians, trainees, and other healthcare professionals. All right, here's our primary endpoint. So we looked at stages of change, and on the bottom in red, I have no intent of making a change all the way up to blue, light blue, as I have been consistently eating a whole food plant-based diet for 6 months or more. What I want to draw your attention to is the green, which represents I recently started eating a whole food plant-based diet. And what you can appreciate is that basically in group A, from baseline to week 6, where we had the intervention, we saw this dramatic increase in uptake of folks that started recently eating a whole food plant-based diet, which was not seen in group B, the delayed intervention group. And I think what's more striking is at week 9 and 12, we followed them further out, and the uptake continued, which was pretty awesome. We looked at the stats for that, kind of looking at the summary of all of these, and you can appreciate that at week 6, there was a statistically significant increase in the readiness to adopt a whole food plant-based diet in Group A. We also looked at the secondary endpoint, which was level of confidence in discussing a whole food plant-based diet with patients on a scale of 0 to 100, and you can also appreciate in Group A, there were more people that were willing to do this. It was very important to look at what were the motivations for adopting a whole food plant-based diet. So I know this is small, but of course on the top I put climate change and sustainability, but it was actually my own health was the primary driver for people wanting to adopt this type of diet. And secondarily, a loved one's health. Climate change came in third. Animal welfare, and you can see role modeling for patients and for family, social justice, and then the least popular one of our group was religion or culture. We asked, how much do you agree or disagree with the following statement? So starting on the top, I learned at least one tangible strategy in red. I've implemented some of these strategies in dark blue, and in light blue, I've discussed or plan to discuss the strategies I learned with my patients. And what's exciting is the vast majority of our participants strongly agreed that they learned all of these 3 things. Finally, we asked likelihood to recommend. How likely are you to recommend this program? And 60% were supporters, 29% were more passive, and only 12% were detractors. So in conclusion, our plant study did meet its primary endpoint. We were able to show that more participants in Group A demonstrated readiness to change to a whole food plant-based diet at our week 6 endpoint compared to Group B. We also met our secondary endpoint, which was confidence in discussing the adoption of a whole food plant-based diet with patients. Confidence in discussing it with patients, which was also greater in Group A compared to Group B. So really this was a pilot study that demonstrated the feasibility of implementing a successful plant-based nutrition education program for healthcare professionals in a medical setting. The obvious limitation is we recruited 95% females, so we clearly need to mitigate that. And so future directions, I think this is where really the excitement starts. We would like to scale this study at Stanford, and importantly, much far beyond that. We're in discussions with a big healthcare center in the Central Valley. I think we need to be thinking strongly about equity considerations, diversity, thinking about all these different factors that go into food choices. And the goal is obviously to recruit a much more diverse group of providers, thinking about many more males, et cetera. And then ultimately we want to determine the impact of this intervention in terms of how, to the extent to which this educational program influences what healthcare providers recommend to their patients. And ultimately, it would be nice to then track their patients in terms of the patient's dietary choices. In closing, with my 12 seconds left, I want to thank Neha Shah, Miriam Mikowski. I want to thank Uma Ayachit, who is our fearless, amazing study coordinator, Carly Arbo, who's a chef and a surgeon, Christopher Gardner, Siri Chan Kalsa, so many others, and so many who have helped to support these efforts. Thank you for your attention.
Good morning, everyone. All right, my name is Wei-ting Chen. I'm the Executive Director of the Food for Health Equity Lab, which is a research group at the School of Medicine. Our principal investigator is Dr. Lisa Goldman-Rosas, whom you'll hear from later today. Really, the goal of our research group is to think about how we can best integrate healthcare and the food system to improve health equity for all. And I'm so pleased to be here today to share some of our very early findings from a study within a study with the support of the Plant-Based Diet Initiative funding. So, all right, I will start with the parent study that we're working on. It is a clinical trial that is funded by National Institutes of Health. The Adelante study is a multi-level diabetes management randomized controlled trial that aims to use produce prescription and whole grains and behavior coaching to improve patient outcomes. And we are currently working with federally qualified health centers on the East Bay to recruit Spanish-speaking Latinx patients who have been diagnosed with diabetes, are considered overweight, and experience food insecurity to participate in our year-long program. And the adults are the primary outcome. We're interested in the index patient is their hemoglobin A1C level at 6 months. And in addition, we're also aiming to recruit up to 2 household members, age 12 and up. We know food decision is a household decision. And we're interviewing them as well to using surveys to understand changes in household food security status, their dietary behaviors, their psychosocial outcomes, and then we also have actually another supplemental study related to health outcomes in adolescent participants. Like I said, this is a multi-level intervention. That picture is a real picture from one of our food boxes. And we are still in the middle of the study. We started recruiting in 2023, and hopefully in a year from now, we'll have some preliminary data to share with you from the parent study. But today, like I said, we are interested in the systems perspective. I would like to encourage you to think about food as medicine and its impact on the agriculture community. Typically, we focus on the health outcomes, but really, from what we've learned in our work in food as medicine, our group currently works with 5 different types of food providers, is that we need to think about the agriculture community. And with support from the Seed Grant, we're actually interviewing some of the the farmers, the growers, and patients to understand how this is really shaping their experience with food in general. And I would like to introduce you to our primary food partner here, Yei Organics. It is a mission-focused food hub that really helps our study to deliver this beautiful produce from farms and their warehouse to people's homes in Concord. Yei Organics was established in 2020 by Cecilia Lara Chavez. Cecilia is here somewhere, to help Latinx farmers find new business opportunities as farmers markets and restaurants just shuttered at the start of the COVID-19 pandemic. So this is a new business. And today, Yei Organics works with anywhere around 20 farmers, and 70% are women-led, at any given time to help them get and maintain USDA organic certification and find new business opportunities. And in one of my interviews, Cecilia shared with me that most of the farmers she works with are recent immigrants, mostly women, who have very limited English skills and are not familiar with how businesses function in the United States. So as a result, they don't always have the best experiences. Sometimes they don't get paid, sometimes they can't negotiate contracts, they are not paid at fair rates. And by working with a food hub, the food hub has mostly small farms, they are actually able to negotiate as a collective fair market value for the produce that they devote their heart and soul to grow. And yet, because of the volume, they can stay competitive when selling to institutional buyers, and can stay competitive with conventional farmers. And also, I mentioned Yei Organics is a mission-focused food hub, so they actually work very hard with nonprofit organizations to get food to people who may not typically be able to afford organic, regeneratively grown foods. So, what have we learned from this on the impact of food as medicine on farmers? First of all, they are actually really very much like the predictability of food as medicine programs. We tend to have set business volume for them, and it's predictable, and we pay them fair market value. And we find that, you will see, these are real pictures from our weekly produce boxes. We talk about food as medicine, we talk about food prescription, but if you're overly prescriptive, it actually makes it very difficult for farmers to fulfill. So we follow their lead. We use what's in season, very much the CSA-style boxes that makes it easier for farmers to do this work. And third, we're still trying to figure out how to communicate the findings of our study to these farmers, but for now, they just appreciate that the work that they're doing goes towards people who need it. They know that they're not damaging the environment, and they're taking care of people in their community. And what's the hardest thing about food as medicine? I call this the last mile problem, getting food from farms to people's homes. That is very difficult, right? So in closing, I just would like to share with you, Know Your Farmer, Know Your Food is an old USDA initiative that I worked on. These are real people, real farms. So these are the farms that currently supply food for our study, and the farmers. You should look up Yay Organics on Instagram. She does a great job of reposting the pictures from our farmers. And we're not just doing this for our generation, we're doing this for our community in the future, for many generations to come. Thank you.
Great. Well, thanks to the organizers. Thanks to Christopher Gardner and the team for supporting this work. I'm a PhD student here in computer science, and this is work done with a wonderful set of collaborators here at Stanford. And our title is What Can Large Language Models Do for Sustainable Food? So, of course, the high-level motivation is familiar to all of us here that factory farming has a number of negative impacts. And I think we've also seen these recent advances in artificial intelligence, which have made a number of great achievements. So these large language models are, for example, passing the bar exam, they're passing the US medical licensing exam. They've recently obtained silver medalist performance in the International Math Olympiad. And as computer scientists, a natural question that we were asking is, what can these recent advances in artificial intelligence do for the transition away from factory farming? And so one line of work we have is focusing on what LLMs can do for alternative protein. So a common practice at these alternative protein companies, and so I'll define alternative protein as substitutes for animal products such as plant-based cheese, plant-based meat, et cetera. So a very common practice at these companies is to conduct sensory panels. So basically you have a current formulation of your product, and then you find a group of trained sensory panel testers, get both quantitative and qualitative feedback, and then go back to the drawing board and revise the product formulation on the basis of this feedback. And so a question that we asked is, can these large language models, which have been trained on a very large volume of food science data, they've been trained on the entire internet essentially, can they be useful in synthesizing both this qualitative feedback, which is just unstructured text that people are providing, as well as the quantitative feedback, for example, rating their satisfaction on a scale of 1 to 10, or rating if it's just right on sweetness or too sweet, et cetera. Can they synthesize all this data to generate suggestions for improvement? And of course, there's one other approach for shifting consumption away from animal products, and there's one school of thought that we don't necessarily need these meat substitutes. We can try to increase adoption of conventional plant-based food instead. And so there's prior work on the Edgy Veggies Toolkit, which is now adopted by Stanford Dining, which has shown the importance of the way we describe food and shifting consumption. So we are also interested in the question of, can these large language models be useful in generating appealing descriptions and creative plant-based recipes? So now I'll go into the specific tasks that we're evaluating these large language models on. So we're first interested in whether these LLMs know anything about the mapping from a product formulation to the way it is perceived by people. And this might seem very ambitious, but there's prior work from Google, a spin-out of Google called Osmo, showing that a technique called graph neural networks can provide a satisfactory model of smell. And this was published in Science last year. So we're viewing this as a starting point for evaluating what these models can do for a similar task of taste. As I mentioned in 2 slides ago, we're also interested in this task of, given a product formulation and the sensory feedback, can these large language models be helpful in revising the product formulation to address the feedback and improve satisfaction? And here we have a visualization of this task 2, in which the LLM can play a supporting role to the food scientists. So our goal is not to automate these food scientists, but to take a human-centered approach instead, where these large language models are playing a supporting role. And task 3, this is similar to task 1, but instead is focusing on conventional plant-based food rather than alternative protein. And task 4 is along the lines of the language of food direction that I had mentioned. Given a plant-based recipe, can we revise this description to promote choosing it over an animal-based recipe? And task 5 is, given a menu, can we revise it to promote plant-based choices while maintaining or improving on a variety of relevant factors such as nutrition, cost, climate impact, and patient satisfaction. So here we're building upon tasks 3 and 4, which are evaluating if these language models have a sense of human preferences as well as are able to provide appealing descriptions. And we're working with 2 data sets. So we're working with a nonprofit called Food Systems Innovation, and they've done the largest sensory panel thus far of alternative protein products, around 5,200 sensory evaluations of over 50 products. So we're working with this data set for tasks 1 and 2. And we also have a large recipe data set from food.com, which contains many plant-based recipes. So in summary, these large language models have shown great promise in a variety of tasks. And we view our work as really the first step here, that in the possible application of artificial intelligence to try to promote plant-based food and the transition away from animal agriculture. Here we're conducting a benchmarking study to just evaluate the existing models. And we defined 5 tasks in consultation with experts and are in the process of evaluating the performance of these models on these tasks. Our preliminary results suggest that in our task 5, the menu revision task, these models can actually reduce emissions by over 60% while maintaining patient satisfaction with their set of choices. And we have several future directions that we're interested in. One is fine-tuning of these LLMs on food science data sets. So currently we're just using the standard large language models that you can interact with, like ChatGPT. But I think a very natural direction is to further fine-tune these models on specialized data sets. And we're also interested in the integration of LLMs with various other types of artificial intelligence methods, such as graph neural networks, as I had mentioned earlier, which have shown promise for olfactory modeling, as well as Bayesian optimization, which is actually currently in use in the alternative protein industry for suggesting experiments on the basis of past results. I'd like to thank my collaborators again and the organizers. Thank you.
Hi, everyone. Good morning. I'm Jessica Hope. I'm a research scientist with the Humane and Sustainable Food Lab here at Stanford in the School of Medicine. And I want to take a step back and think about plant-based meat alternatives, because we're doing a lot of talking about that, and we're very grateful to our benefactors. And we're interested in the role of plant-based meat or plant-based meat analog, excuse me. We're interested in what that's really doing. And I am very lucky to work on this project, to work with our lab's co-founder and PI, Maya Mather, and with our colleague, Jacob Peacock. And Jacob has done some work that's shown that we have this underlying assumption that plant-based meat analogs, that if we put it out there and they're available, then people will start eating them. And he's done some work that shows that perhaps even if plant-based meat analogs are the same price as regular meat, as animal-based meat, even if they're just as delicious, even if they're just as convenient, maybe people aren't eating them. So we're looking into that. And we're also interested, in what is being replaced. And that seems like a silly question. Obviously, they were made to replace animal meat, but is that really what's happening? So plant-based meat sales skyrocketing, so that seems great. People must be eating plant-based burgers instead of animal-based burgers. But meat sales are also still going up. So we're interested in what's happening here. Who are the people eating the plant-based meat, and what is being replaced when they do that? Are plant-based meats actually working as a step forward toward a plant-based diet or not? Or are they just giving vegetarians more options? So this is especially interesting from a health perspective, because if someone switches from, say, a cheeseburger to a plant-based burger, they're getting more fiber. Any fiber. They're getting cholesterol. So that's great. But if someone's switching from eating tempeh to eating a plant-based meat analog, that might be a step in the wrong direction. If they've been eating beans, a whole food, and then they're switching to a plant-based analog, that is not the direction. We want to go toward a whole food plant-based diet, not away from it. So we wish that we could just get a huge data set on this. We wish we could see what everyone in the world's been buying and then what they started buying instead. But we don't have that data, so we need to make our own. So we're doing a study on how people order tacos. And we realized looking at Mexican menus, it's a perfect research opportunity because on Mexican menus in the US, you order the type of food and then you order the flavor of your food. So we can get right to our outcome measure instead of trying to look at what happens when someone orders fried chicken versus a cheeseburger versus teriyaki tofu. So we really like how equivalent these are. But we don't want to do a food truck because that's such a small sample and isn't as generalizable. So we chose to look at Chipotle's menu because Chipotle is ubiquitous and we can generalize it. So this is actually from Chipotle's website. This is exactly what their menu looks like. They always have at least 4 meats and then a veggie option. And then Sofritas is their plant-based meat analog. So we added so a third of the participants in our study will see this menu. That'll be their option when we ask them to order a taco. And then another third will see that menu plus our own plant-based analog, which is fictional, which I called Chickenitas. And we really like, this is another reason we're using Chipotle, because we really liked how clean their menu was, so it was easy to make a little fake item. So it'll be a 3-armed randomized trial with 3,600 participants. And the reason we need so many participants is because, unfortunately, very few people get the vegetarian option. So we need, in order to achieve statistical significance with the statistical tests we want to do, we need this number of people. So a third will see in arm 1, that represents the condition that you get at a food truck, where you have some meats and then just a nondescript veggie. And then arm 2 is actually what people are getting at Chipotle, and arm 3 adds the chickenitas. So our hypothesis is that the more plant-based options there are, the more people will choose plant-based options. So we have a whole lot of, I've spent a lot of time on survey design, and I don't have time to cover everything. We do have an awareness check, we have a couple attention checks, and we have a bunch of decoy questions to try to throw them off. We don't just want to hand them a taco menu and say, okay, what would you order? We want to bury it in a bunch of questions to try to get away from social desirability bias. The reason that we chose chickenitas as our additional item is because we're also interested in the specificity of the intervention. So we want to know specifically, does adding a plant-based chicken item, does that specifically displace chicken ordering versus other meats? So do I still have a couple minutes? So our decoy questions are about T-shirts and pens. We were trying to think of things that people regularly order. We've had good luck in our pilots with fooling people about what our point is. So an awareness check in a study is asking people, what do you think we're studying here? And we want them to not be sure. We want them to be a little confused because we don't want them to think, oh, this person wants me, they care about what exactly taco filling I'm ordering. So we're really pleased that this has been working out. A lot of people, when they are making a change when they're making a step toward a whole food plant-based diet, and they're making a change for sustainability reasons or for health reasons, they'll often switch from cows to chickens and fish. And so that means they're switching from large animals to smaller animals. And unfortunately, then that means that many, many more animals are being subjected to the terrible conditions on factory farms. So, for example, if a consumer were to usually eat a cow in a year, over the course of a year, and then they switch to eating 100 chickens over the course of a year, that's 100 times as many animals who are suffering in those conditions. And it also is 100 more genome hosts available for a virus to mutate into the next human pandemic. So we're very hopeful that having a chicken-based analog will lead more people to switch over from regular chicken to plant-based chicken. We have our ADDReB approval, and we're pre-registering our study, so we should have results really soon, so stay tuned. And I'd like to thank the PBDI for supporting us. And thank you to everyone in this room. You're all here because you care about this. You're all doing really hard work. And we really appreciate, because big changes are needed in the food system, and we really appreciate your work in it. Thank you.